Hello everyone. This lecture is for subject design planning and control of production system, which is a open elective subject for third year BE student in MBM Engineering College Jodhpur. This subject has 5 units, out of which 3 units we have covered in previous lectures: production planning, scheduling, inventory systems. In today's lecture we will be covering the 4th unit, project planning and control, and the next lecture will be on the 5 unit supply chain management. As far as this subject is concerned and the topics we are covering, I would recommend the standard books based on industrial engineering, production planning and control, production and operation management. So other than attending these lectures, students should follow these standard books to get more numerical, more case study on these topics. Let us start this lecture. This lecture is based on the 4th unit, production planning and control, and the learning outcomes of this lecture are network control, control cost considerations and optimization, resource allocation and leveling, aggregate production planning. So we will be covering these topics. We will be having numerical on this, then we will try to understand different terminology and concepts used for this topic. Let us start with the basic definition of project management. A project is an interrelated set of activities with definite starting and ending point and results in a unique product. So you get a product in the end, but that particular process must have some starting point and some ending point. So examples of projects are shown on the screen right now: constructing a bridge, dam, highway or building, or producing an airplane, missile or large machine. Other example of projects are introducing a new product, installing a large computer system, redesigning the layout of plant or office, construction of ships. So these are few examples of the projects. Basic steps in project management are: describe the project, develop a network model, insert time estimates, analyze the model, develop the project plan, and periodically assess the progress of the project. So these are the basic steps once you go for managing any project. So it starts with the design of the project, then you use network models to get the total cost and time of that project, then you insert the estimated time that will require to complete the project, then you analyze the model using different techniques, then you develop a project plan, and you should always periodically assess the progress. You should evaluate the progress of the project, so accordingly you can take some corrective measures for the success of the project. Network is a graphical representation of project activities arranged in a logical sequence and depicting all the interrelationship among them. So you have certain steps, you have certain activities, you have certain event in a project, and the way to control those events and to get some relationship among those activities and events, you have network. So a network is basically graphical representation where you can easily show the connection between various activity and events for any project. It has two very popular technique, PERT and CPM. So we will try to understand the difference between PERT and CPM, how we can use to successfully manage any project. So program management and review technique, that is also known as PERT, is appropriate for projects where time needed to complete different activities are not known. So this is the condition for PERT. While for CPM, it is used for projects which are recurring in nature, which are repetitive. So we'll now, these two methods are common approach for designing the network and for ascertaining its critical path. So using these two techniques, we can get the critical path, which gives you the idea of total time required to complete a project and total cost required to complete that project. So these two have certain limitations, certain characteristics, and these two techniques are different, and we will see the difference between these two techniques. So here in this screen right now, we are differentiating between PERT and CPM on the basis of focus. So focus for PERT is on time, while CPM focus on time cost trade-off. While PERT orients to the event, while CPM is activity oriented. You consider unpredictable activity in PERT, while CPM is used for the predictable activities. In PERT, the jobs are non-repetitive in nature, while in CPM you get repetitive nature of jobs. Probabilistic model is used for the PERT, while CPM uses a deterministic model. There is no differentiation between critical and non-critical activity in PERT, while CPM differentiate between critical and non-critical activities. And PERT is suitable for research and development project, while CPM is useful for non-research project like civil construction, shipbuilding and other sort of projects. Important here is to get the critical path in any network analysis. As I said earlier, you always need a critical path in network analysis to get the possible time you require to complete a project, the overall cost that you will have to pay to complete a project. So you can easily get the idea of total time required using this critical path method. And to understand this critical path method, certain parameters, certain quantities are required as shown on the screen. Suppose a activity is shown by ij, where tail event is I and head event is j. Ei is the earliest occurrence time of any event I, while Lj is the latest allowable occurrence time of event j. So for each and every event there is the earliest time and latest time. So we always need to consider these two timings to get the critical path. That will explain you during the solution of the numerical problem, where we will be having a numerical problem that will make you clear about these two parameters. Then comes the estimated completion time shown by Dij. Then you always try to calculate the earliest starting time of activity and earliest finishing time of activity. Similarly, you calculate the latest starting time of activity and latest finishing time of activity. So all these parameters are very important to get the critical path of any project, and that we will be using in our numerical in this lecture. So it has certain procedures. So is procedure for getting the critical path as first step as determination of earliest time. So you go forward from the starting and you calculate the earliest time of each and every event. Next comes the backward pass computation, through which you calculate the latest allowable time. So if you move forward from the beginning, you will calculate the earliest start time, and if you move backward from the end, then accordingly you will be getting the latest allowable time. That I will show you for your particular example in this lecture. And then comes the determination of floats and slacks time. This is the difference between the latest event and earliest event time. So three important steps are calculating the earliest start time, calculation of latest start time, and the difference between these two quantities. So all these three steps you need to calculate for each and every event, and that will give you the critical path of a particular project. So how you determine the critical path? So events with zero slack time, that means earliest start time and latest start time is same, that is your zero slack time. All those events are known as critical events. So we will calculate earliest start time and latest start time for each and every event, and if you get the difference between them is 0, then that event is known as critical event. While critical activities are known as those activities with zero total float. So again there is no difference between these two timings that will show you during the solution of your problem here in this lecture. And the sequence of critical activities in a network is known as critical path. So it is the longest path in network from starting event to ending event, and defines the minimum time required to complete the project. So ultimately, using this network modeling, you get a critical path that is the path that requires minimum time. So ultimately it takes less cost to complete the project. So ultimately, using different parameters for a particular problem, you calculate these timings, you calculate the difference between these timings, then you can decide which one is your critical path to complete the project. So we will try to understand this critical path method using this problem. a problem is shown on the screen right now. You have to determine the earliest starting time and latest starting time for all the nodes and identify the critical path for the following network. As shown on the screen, there are 10 events, 1 to 10, and if you move from 1 to 2, the time required is 10 minutes, while if you move from 2 to 5 event, it requires 8 minutes. So corresponding times are shown on the screen. There are 10 nodes. So what we need here is to get the critical path. We need to calculate the earliest starting time and latest starting time for each and every node. So if you try to calculate the earliest starting time, you should start from the node 1, and if you want to calculate the latest starting time, you should start with the node 10. So earliest starting time starts from the first node and moves forward, while if you try to calculate the latest starting time, it starts with the last node, that is 10, and it moves backwards. So let us see how we solve this problem. So as shown on the screen, if we start to calculate the earliest start time from the node 1, you can easily get the earliest start time of node 2, that is 10, because the total time required from moving from 1 to 2 is 10. So for node 2, earliest start time is 10. Similarly, for other nodes, you can easily calculate the earliest start time by just adding the total process time in previous event. So here if you look at the node number 6, so for node number 6, the earliest start time is the addition of the time required from moving from node number 1 to 4 and 4 to 6. So to reach up to node 6, we have to move from node 1 to node 4 and then node 4 to node 6. So total time required is 16. So earliest start time for node 6 is 16. So similarly, for each and every node, we calculate the earliest start time by just adding the process time from one node to another node. Now if we try to calculate the latest starting time, it starts with the last node, that is node 10 here. So if you move backward from the node 10, so you just start with the for the last node, the earliest start time and latest start time must be same. So it is 37 right now. If you calculate the earliest start time of all the nodes, the total sum comes as 37. So we will start with the latest start time 37 from the node 10, and we just subtract the process time from the previous node. So if you move from as shown on the screen, if you move from node number 10 to node number 9 here backward, so you just reduce you just subtract 15 minutes from the 37, so that gives you latest start time as 22. Similarly, if you move from node number 9 to node number 6, so you just need to subtract 5 minutes from your latest starting time. So latest starting time at node 9 is 22, and latest starting time for node 6 will be 17 by subtracting 5 from 22. So you are just reducing the total time and moving backwards. So similarly, you get the latest starting time for all the nodes. So now after calculating the earliest starting time and latest starting time for each node, we can easily calculate the difference between these two timings, and those difference are shown in the table right now. So the simple graphical representation as shown in previous slide is now we have presented in terms of table. So there are certain activities. Second column is the process time, then we calculate the earliest starting time, then we calculate the latest starting time using that model, and then we calculate the difference between starting time and latest time. So that is known as the float time. So you can see from this table, at least for activity number 1 2, for activity number 2 5 and 5 7 and 5 8, and for activity 7 10 and 8 10, the float time is 0. So for those activities which have float time 0 are known as critical activities, and these activities will lead you to the critical path. So if you you just note down, if you get the idea of these activity, and if we take these activities out of this table, The critical nodes are 1, 2, 2, 5, 5, 7, 5, 8, 7, 10, 8, 10, which we have seen on in the table that they have 0 float time. So these are the critical nodes. So there are possible critical paths 1, 2, 5, 8, 10 and 1, 2, 5, 7, 10. So these two are the critical paths which will give you the less time to complete the project, because they have 0 float time in between the nodes. So this is how we get the critical path method for any project. Next comes the resource allocation and labeling. There are two types of resource problems: resource smoothing and resource labeling. Suppose only 125 lakh per annum may be available to any project, and if you unutilize during the year, the remaining amount lapses. So if you don't use any fund, that ultimately lapses. The resource analysis used for this type of case is known as resource smoothing. So it depends on the fund available. So if you manage that fund, if you properly utilize that fund, that comes into the problem of resource smoothing. While the second problem for the resource allocation is resource labeling. I will try to explain using an example. Suppose in present day labor situation, one company cannot have 100 laborers yesterday, 30 today and 80 tomorrow. So if there are variety in number of laborers each and every day, you cannot complete a project within the given time frame. So if this is the case where you are having the variety of numbers of laborers each and every day, you get different number of laborers, then you know that once a labor is hired, it is difficult to hire him again. So if you hire a particular labor, you cannot deny a job to him. So you need to keep laborers busy all the time. So you need to find a common optimum number of laborers that can be utilized efficiently to complete your project. The rate of usage of labor must be uniform. So this kind of analysis used for the problem of resource labeling. So resource smoothing is based on the fund allocation, while the resource labeling is based on the labor allocation. So as I said earlier, resource smoothing means there may be some ceiling on the availability of resources in a period, and you need to spend it efficiently. Similarly, for resource labeling, you may have the variety in the number of laborers you are getting in different days. So you need to get that laborers numbers uniform, so that you can complete your project well within the time and in minimum cost. Then comes the aggregate production planning. It acts as an interface between strategic decision and short-term scheduling, which guides firms' day-to-day operations. So it is a intermediate level planning. As we discussed in previous lectures, there are three kind of planning: long-term planning, short-term planning and intermediate planning. This aggregate production planning comes into the category of intermediate planning, because it is the interface between the strategic planning and short-term planning. It's a general approach to altering a company's production schedule to respond to forecasted changes in demand. So if you suppose you are getting a variation in your forecasting demand, you can easily make changes in your system so that you can complete your demand and supply chain within the given constraints. Aggregate production planning decision options are modification of demand and modification of supply. So you suppose you are getting variation in demand and supply for your company, then the aggregate production planning helps you to decide how to modify your demand and how to modify your supply. So using the appropriate techniques, you can modify your demand, you can also modify the supply, so that you can run your project, run your company, run your production in a smooth manner. For modification demand, the differential pricing is like reducing off-season item rate and reducing the hotel rates in off-season. So these are the examples. Means you may have difference in the pricing, that is to keep your demand in control. Similarly, advertising and promotions are important, because they are used to increase demand during off period and to shift demand from peak period to off period. So your demand depends on advertising and promotion also. Suppose you want to increase the demand, you just use advertising and promotion extensively, and suppose you don't want to create demand, then you just go slow with your promotions activity. Then comes the backlogs. Through the creation of backlogs, the manufacturer asks customers to wait for the delivery of products, thereby shifting the demand from the peak period to off period. So this is one of the way of modifying the demand. Last one is development of complementary products. Because producer who produces products which are highly seasonal in nature applies this technique to keep the demand in control, like refrigerator company produce room heater, TV company produces DVD, etc. So these are the various techniques used to control the demand that will help you to run your business smooth. And there are different techniques to modify the supply also. So if you want to keep check on your supply, you want to keep your supply smooth, there are certain activities, certain techniques for this. One is hiring and layoff employees, because the manpower varies from peak period to off period, so accordingly firing or laying off employees followed without affecting the employees morale. Then comes the overtime and undertime. So overtime and undertime are common options used in cases of temporary change of demand. So if you are having a temporary change, then you just use overtime and undertime with your labor. You can also use the part-time labor, because this method is attractive as the payment of part-time labor is less. Then you can use the subcontracting also. The subcontractor may supply the entire product or some of the components needed for any product. And last one is the carrying inventory. It is used by manufacturer who produces item in a season and sell them throughout the year. So if you want to manufacture a particular product in a particular period and you want to keep supplying throughout the year, you just keep you can carry inventory to keep your stock available to supply in any period of the year. So in this lecture we have discussed about network model, control cost and optimization, resource allocation and leveling, and aggregate production planning. So this was all about the unit 4 of design, planning and control of production system subject. And in next lecture we'll be covering the last unit, that is supply chain management, that will cover this subject. And accordingly students should also go through the lecture notes of this subject, and they should also refer the standard books for getting more idea about this subject. Thank you.